Hi everyone, welcome to my channel. Today we're diving into the world of big data. Every day we generate massive amounts of data through social media, online shopping, banking, and mobile apps. This data is collected, stored, and analyzed for research, business, and innovation. But the scale is enormous, sometimes measured in terabytes, petabytes, or even more. This vast amount of information is what we call big data. Big data refers to data sets so large, up to 10 to the power of 15 times bigger than regular databases, that traditional tools can't handle them. To truly understand big data, we look at the 5 V's: volume, velocity, variety, veracity, and value. First, volume. This means the sheer amount of data. Think of massive data centers or endless social media feeds. Next, velocity. Data is generated and processed at incredible speeds, like real-time stock market updates or sensor data. Variety means data comes in many forms: tables, images, videos, and even audio files. Veracity is about data quality, making sure information is accurate, like detecting fake news or calibrating sensors. Finally, value. This is about turning data into insights, like business dashboards or recommendation systems. So how does big data work? Let's walk through the big data pipeline step by step. First is data generation. Data comes from mobile devices, IoT sensors, and websites. Next is data ingestion. Data streams or pipelines move information into the system. Tools like Apache Kafka are often used here. Then comes data storage. Distributed storage systems like Hadoop or cloud storage keep all this data safe. Data processing is where servers run analytics or machine learning to make sense of the data. Data analysis uses tools like SQL, Python, or R to extract insights and patterns. Finally, data visualization. Charts, dashboards, and reports help us understand and share results. Let's look at some popular big data technologies. First, Hadoop. Hadoop is an open-source framework that stores and processes large datasets across clusters of computers. Next, Hive. Hive is a data warehouse tool built on top of Hadoop. It lets you use SQL-like queries to analyze big datasets. Scoop is a tool that helps transfer data between Hadoop and relational databases, making it easy to import and export large amounts of data. Finally, Spark. Apache Spark is a fast, in-memory data processing engine that can handle both batch and real-time analytics on big data. In this video, I'll introduce you to these technologies, and in future videos, we'll explore them with hands-on examples. Hey everyone, welcome back to my channel. In today's video, we'll discuss one of the most important technologies in big data, Hadoop. Hadoop is often considered the starting point for big data technologies. But before we get into its working process, architecture, and components, it's important to understand why Hadoop was created. Why was Hadoop needed? Back in the early 2000s, data was growing rapidly. Emails, search queries, online transactions, images, and more. Traditional databases and systems were struggling because they could not store such huge amounts of data. Processing was slow and required expensive hardware. Scaling up meant buying bigger machines, which was costly. So, the world needed a new way to store and process big data efficiently. How did Hadoop begin? What's its history? The story of Hadoop actually starts with Google. Google published research papers on 2 key technologies: Google File System, a way to store very large files across multiple machines, and MapReduce, a programming model to process massive data in parallel. Inspired by these ideas, in 2005-2007, Hadoop was developed as an open-source project by Doug Cutting and his team. Originally, Hadoop was part of a project called Nutch, a search engine project. Later, Hadoop became its own framework. In 2008, Hadoop became a top-level project at the Apache Software Foundation. Companies like Yahoo, Facebook, LinkedIn adopted Hadoop. This was a turning point because now even smaller organizations could use Hadoop to manage massive data without relying on expensive systems. What is Hadoop? Why is it so famous? Hadoop is an open-source framework written in Java, designed to store and process huge amounts of data efficiently. The key idea behind Hadoop is distributed computing. Instead of using one super powerful computer, Hadoop splits the work across many normal machines called nodes. These nodes work together in parallel, making processing faster and more reliable. If one machine fails, Hadoop can automatically recover the data and continue processing. That's why Hadoop became so popular. It is cost-effective, scalable, reliable, and fault-tolerant. What are the key components of Hadoop? Hadoop has 4 main components: HDFS, MapReduce, Yarn, and Hadoop Common. HDFS. Hadoop Distributed File System stores huge datasets by splitting them into blocks and distributing them across machines. It provides data replication so data is safe if a machine fails. MapReduce, the original processing engine. Map splits work into smaller tasks, Reduce combines results. Example, counting words across thousands of documents. Yarn, yet another resource negotiator, manages cluster resources and decides which machine should do which task. Hadoop Common, a set of shared libraries and utilities that support the other components. Hadoop solved three major problems. Scalability, can handle petabytes by adding machines. Cost effectiveness, runs on commodity hardware. Fault tolerance, system continues if a node fails. This is why Hadoop became the foundation for many big data tools like Hive, Pig, HBase, and Spark. In my next video, I'll explain each component with examples and diagrams. If this helped, like, share, comment, and subscribe. Thanks for watching and see you in the next video.
Let's look at another real-world MapReduce example. Analyzing server logs to count different types of errors. In the map phase, each log entry is scanned and the error type is extracted like error_404.1 or error_501. During shuffle and sort, all entries with the same error type are grouped together across the cluster. In the reduce phase, the system counts how many times each error type appears, giving you a summary like error_404, 120, error_500, 45. This way, MapReduce helps IT teams quickly find which errors are most common in huge log files, making troubleshooting much easier. Hey everyone, welcome back to my channel. Today, we explore one of Hadoop's core components, MapReduce. If you're new to big data, this will make distributed processing clear. So, what exactly is MapReduce? It splits jobs into map and reduce phases so work runs across many machines. Map phase, data is broken into key value pairs. Example pair, Hadoop 1, shuffle and sort, same keys are grouped together across the cluster. This moves related values to the same reducer for aggregation. Reduce phase. Values for each key are combined to produce the final output. So MapReduce processes huge data by dividing, grouping, and aggregating in parallel. Real example, word count. Count how often each word appears across many documents. Map scans text and emits pairs like Hadoop 1, Big 1, Data 1. Shuffle groups same words together. For instance, Hadoop 1, 1, 1. This happens automatically across nodes, no single machine holds all data. Reduce sums values, Hadoop 3, end result, a frequency table of words, all processed in parallel. Beyond word count, log analysis, recommendations, indexing, fraud detection. Let's look at another real-world use case analyzing server logs to count different types of errors. Imagine you have thousands of log files from many servers, each recording events like info warning error. Manually checking these logs would take forever. Here's how MapReduce handles it. In the map phase, each log entry is scanned. When an error appears, the script extracts the error type. It emits a pair like error_404, 1, error_501. This happens for every line in every log file. Next, the shuffle and sort phase groups the same error codes together across all your logs. All the error_404 pairs are collected in one place. All the error_500 pairs are collected in another, no matter which machine they came from. Finally, in the reduce phase, MapReduce adds up the counts for each error type, error_404, 200, error_500, 57, and so on. The result is a clear summary showing how often each error occurred across your entire system. With MapReduce, even massive amounts of log data become easy to analyze, helping you find and fix problems faster. That was MapReduce, a simple way to process huge datasets in parallel. If this helped, like, share, and subscribe for more Big Data Explained. See you next time.
Companies like Google or Facebook store and manage huge amounts of data? Let's find out. Hey everyone, welcome back to the channel. Today, we'll learn what HDFS is and why it matters for big data. Short and simple. HDFS stores massive data by splitting and distributing it across many machines. What is HDFS? It's Hadoop's distributed storage system that holds files as blocks across a cluster. Think big files split, stored across many machines. That's the core idea. How does it split data? Picture cutting a big watermelon into slices to share easily. Each slice is like a block, smaller, movable, and easy to distribute. Let's use numbers. Suppose we have a 10 GB file. How many blocks is that? With a default 256 MB block size, 10 GB divided by 256 MB gives 40 blocks. So the file becomes 40 pieces. Those 40 blocks can be stored across many machines in the cluster, letting them be processed in parallel. But what if one machine fails? Do we lose data? HDFS solves this with replication. Each block is stored on multiple machines. For example, block 1 might be on machine A, machine B, and machine C. So losing A still leaves B and C. HDFS also re-replicates missing copies automatically when it detects failures. Imagine a library with 1,000 books. If all are on one shelf and the shelf breaks, we lose everything. But if books are spread across shelves and duplicates exist on other shelves, one broken shelf won't destroy the collection. Scalability. Add more machines to store more data. Fault tolerance. Replicas keep data safe even if machines fail. Parallelism. Many machines process different blocks simultaneously for speed. Cost-effective. Runs on ordinary hardware, not expensive servers. Next video, we'll cover HDFS architecture, NameNode, DataNodes, and how they coordinate. If this helped, like, share, comment, and subscribe for more big data lessons. See you next time.
Welcome back. Ready to dive deeper into HDFS? Let's start with a question. What are the main types of nodes in HDFS? Great question. HDFS has two main types of nodes, the NameNode and the DataNodes. Next question. What is a node in HDFS? A node is just a computer or server inside the Hadoop cluster. So what does the NameNode do? The NameNode is the master node. It stores metadata, information about your files, like their names, how they're split into blocks, and where those blocks are stored. Think of metadata as the table of contents for your data. It tells you what's inside and where to find it. Why is the NameNode so important? If the NameNode goes down, you can't access your files. The cluster won't know where anything is. Now, what about data nodes? Data nodes are the worker nodes. They store the actual data blocks and send updates to the NameNode. There are usually many data nodes in a cluster, and they regularly send a heartbeat signal to the NameNode to say, "I'm alive." What happens if a data node fails? No worries. HDFS keeps copies, called replicas, of each data block on different data nodes. Think of it like making photocopies of important documents and storing them in different drawers. If one drawer is locked or lost, you still have your documents in another drawer. This way, even if one data node fails, your data is still safe and always available. This system is designed so beginners don't have to worry about losing their files. For example, imagine you have 3 friends and you give each of them a copy of your favorite photo. If one friend loses their copy, you can still get the photo from the other 2. HDFS works in a similar way to keep your data safe. Let's make it real with an example. Imagine a library. The NameNode is like the librarian. The librarian doesn't hold all the books, but knows exactly which book is on which shelf. The data nodes are the shelves. They hold the actual books, the data blocks. If one shelf breaks, no problem. The same book is on another shelf. So to sum up, NameNode is the master, stores metadata, and manages the file system. Data nodes are the workers, storing the real data and sending updates. That's the basics of NameNode and data nodes in HDFS. Stay curious and don't forget to like, comment, and subscribe for more data engineering content. Hey everyone, welcome back to my channel. In today's video, we're going to discuss another very important component of Hadoop Yarn. If you're a fresher in big data, this concept will help you clearly understand how Hadoop manages its resources and runs applications efficiently. So, what exactly is Yarn? Yarn stands for Yet Another Resource Negotiator. It is the resource management and job scheduling layer of Hadoop. In simple words, Yarn makes sure that the computing resources in a Hadoop cluster, like CPU, memory, and network, are used properly and shared across different applications. Before Yarn, Hadoop was mainly designed to run MapReduce jobs only, but with Yarn, Hadoop became much more powerful. Now the same cluster can run multiple processing models, not just MapReduce but also Spark, Hive, Tez, and machine learning applications, all on the same data. This makes Hadoop a general-purpose big data platform, instead of being limited only to MapReduce. Let's see how Yarn works in Hadoop. It has 3 main parts. 1. Resource Manager, the master that manages all cluster resources. 2. Node Managers. These run on each data node and manage resources like CPU and memory on that machine. 3. Application Master. Each application has its own AM that requests resources from the RM and coordinates tasks. A user submits a job. The resource manager decides where to run it. Node managers provide the needed resources. The application master executes tasks on nodes and monitors them until completion. So the flow is submit job, RM schedules, NMs allocate, AM runs tasks and monitors. Let's take a simple real-world example. Imagine you're at a college library. The resource manager is like the head librarian, who decides how to assign study rooms to students. The node managers are like the individual study rooms, each with a certain number of chairs and tables. The application master is like a group leader, who books a room from the librarian and assigns seats to group members. So, Yarn ensures that every student group gets enough space without wasting resources, and multiple groups can study at the same time. So to summarize, Yarn is the resource manager of Hadoop. It's important because it allows multiple processing engines to run on the same Hadoop cluster, and it works by coordinating resources between resource manager, node managers, and application masters. I hope this video made Yarn easy to understand with a simple real-time example. If you found this useful, don't forget to like, share, and subscribe for more big data and data engineering content.
What is Hadoop? Hadoop is a free tool that helps store and process huge amounts of data using many computers working together. It is reliable and can grow as your data grows. What is HDFS? HDFS is Hadoop's way of saving files. It splits big files into blocks and stores copies on different computers, so your data is safe even if one computer fails. What is Yarn? Yarn is like a manager. It gives out resources and schedules jobs so different programs can run on Hadoop at the same time. What is MapReduce? MapReduce is a way to process data in 2 steps. First, it sorts data into groups, then it adds up or combines the results. Can you give a simple MapReduce example? Sure. For word count, MapReduce counts how many times each word appears in a document. How does Hadoop keep data safe? Hadoop saves copies of each piece of data on different computers. If one copy is lost, others are still there. What if the name node fails? If the name node fails, Hadoop can't find files. To fix this, it uses 2 name nodes and a tool called Zookeeper to switch if one fails. What is the small files problem? Too many small files can slow Hadoop down. You can fix this by combining files or using special storage like HBase. How does Hadoop process big data fast? Hadoop splits data into blocks and works on them at the same time using many computers. This makes it much faster. What file formats does Hadoop use? Hadoop can use text files like CSV and JSON, or special formats like Avro and Parquet that are good for big data and analytics. What is the role of the secondary name node in Hadoop? The secondary name node is not a backup. It periodically merges edit logs with fsimage to keep NameNode metadata compact, preventing memory bloat. How does Hadoop place replicas for fault tolerance? With a replication factor of 3, Hadoop stores 1 replica locally, 1 on another node in the same rack, and 1 on a different rack. This ensures data is safe even if a rack fails. Why are large block sizes important in Hadoop? Large blocks reduce the number of blocks, lowering NameNode metadata and improving throughput by minimizing disk seeks, like reading a book in chapters instead of single pages. How does Hadoop handle data node failures? If a data node fails, Hadoop reads from other replicas and the NameNode schedules re-replication, ensuring no data is lost. What are key Hadoop ecosystem tools? Hive enables SQL analytics on Hadoop. Pig is for ETL scripting. Scoop moves data between Hadoop and databases. Flume ingests streaming logs. Oozie schedules workflows. HBase provides NoSQL storage. How does a typical Hadoop data pipeline work? Example: Scoop imports MySQL data, Hive or Spark processes it, and BI tools like Tableau visualize the results, turning raw data into insights. What is high availability in Hadoop? High availability uses active and standby name nodes, Zookeeper for failover, and fencing to prevent split brain, keeping the cluster running even if a name node fails. What is Hadoop Federation? Federation allows multiple name nodes to manage separate namespaces, improving scalability for very large clusters, like having several librarians for a huge library. How does Hadoop write and read files? For writes, the client contacts the name node, splits files into blocks, and stores them on data nodes with replication. For reads, the client gets block locations and streams data directly from data nodes. What changed from Hadoop 1, X to 2, .x question mark, Hadoop 1, X only supported MapReduce with a single job tracker. Hadoop 2, X introduced Yarn, enabling multiple processing frameworks and better scalability. How do you solve the small files problem in Hadoop? Use HAR archives, combine files, or store small records in HBase to avoid overloading the NameNode with metadata. What's the difference between HDFS and HBase? HDFS is a distributed file system for batch processing. HBase is a NoSQL database for random real-time reads and writes on top of HDFS. What are real-world Hadoop use cases? Hadoop powers log analysis at scale, fraud detection pipelines, recommendation engines, and data warehousing for BI and analytics. What should you remember for Hadoop interviews? Know HDFS, Yarn, Replication, high availability file formats, and ecosystem tools. Pair each definition with a short example to stand out in interviews. Want a PPT with all Quanda as slides? Say yes in the comments, like, share, and subscribe for more interview prep.
Thank you for watching. Please subscribe to my channel and please share and comment.